So I would like to welcome all of you to this third edition of the International Symposium on square bamboos and the geometry. So actually, we have had a long history in the Simon Stevin Institute for Geometry. I'll tell a bit more about this. But Simon Stevin was a Flemish mathematician, engineer, and his famous saying was, "Wonder en is geen wonder," which means if a miracle is no longer a miracle if it can be explained by geometry or mathematics. So, so my own work, I'll tell a little bit my own work for this background because let's say sometime like almost 25 years ago, I made some discoveries. And in the first decade, we did a lot of exploration, graphical software, diffusion into mathematics. And I came into contact with many mathematicians during that time. And that was a bit surprising for me because I wanted to reach out mainly to biologists and maybe physicists. But anyway, so that's where we are today. So in the first decade, let's say, we had some fun, but things went not as planned also. And that's why in the second decade, we built actually a kind of stable and foundations, both in science and mathematics, with rigorous testing against other methods. We built the antenna company with Diego Caratelli. We ship now maybe like 60 million antennas. And our philosophy is based on nature and also building a broad scientific network. And then in the next decade, I really want to spread our wings, our R&D wings, bridging pure science and research and applications, build new technologies, build, and so on and so forth. And this symposium is basically very important for these goals because we want to bring together people in the same. These are some of my applications. But what is most important for me over all these years is the true pleasure of friendly collaborations. And I'm sorry, actually, it's an old slide. I should add many more people, some on a bridge like Temel Hermes and Revas Grigolia, and so on. And also on the lower left, you see Nanjing Forestry University team of Peijiang, who played a pivotal role in establishing our methods as a scientific method. And Weiwei Wang, the first speaker, will delve into that. There's a bit of history because we already started thinking about having meetings a long time ago, back in 2008. I see Simon Stevin Institute for Geometry. The logo on the left is, let's say, the logo for the Simon Stevin Institute. And we already gave some Simon Stevin prizes to Bang Yancheng and Paolo Ricci, who will also speak at this seminar. But a very important meeting was the 2015 Salerno Tbilisi meeting, picture on the right. And that was, we co-sponsored that. And but at that time, we also thought it would be continued in over the years, but this not happened. So let's say, and given all these movements and COVID, of course, I thought it would be a good idea to have an international symposium on square bamboos and the geometry. So we had also these publications like topics in modern differential geometry, modeling in mathematics, Athena transactions, and now Athena transactions or the transactions proceedings of the last year. But I want to stress again the philosophy. We want to have a free symposium, no strings attached, to bring together botanists, biologists, technologists, physicists, geometers, and just look at what is cutting edge and how do we transcend boundaries. Because and why I wanted to pick a very special name, square bamboos, because my work from 93 onwards and then going to 1997 allowed us to look at a unified way and many natural forms and phenomena. And it started with square bamboos and later also starfish and all that. On the other hand, geometry comes from a wonderful book by Robert Osserman. The geometry is a very old tree, and branches and roots are still being made every single minute. So, and yeah, 2 years ago we met also with Matthew Hay, and he also is a mathematician, Chinese mathematician, but in Florida, and he wrote this poem. These texts are from the website, but let's say unity embraces various forms of geometry and algebra. The beauty of nature is generally geometrical and algebraical, and so on. So that's the goal, this unity and these observations and inspirations. What I want to go forward to is if we look at what's happening in physics, there's this famous quote of unreasonable effectiveness of mathematics in the natural sciences, but that's basically on inanimate matter. And Eugene Wigner also refers to inanimate matter in his epochal paper. But there was a famous mathematician, Gelfand, in Moscow, who ran a seminar, a biology seminar, mathematics. There exists yet another phenomenon which is comparable in its inconceivability. That is the equally inconceivable ineffectiveness of mathematics in biology. So any animate matter. Then if we go back, if we take a step back, the famous geometer or topologist Rene Thom says, nature presents itself in forms and phenomena. And my work is basically looking at that, let's say, in the footsteps of Gabriel Lamé. Why geometry? Huh? So should we choose algebra that starts out with confidence to try and find a solution, or geometry that starts out with promising nothing, but very often delivers a solution to the problem along with many other solutions to many other problems that weren't even asked for, but could simply be harvested along the way? And then we found, of course, Lamé's superellipses and supercircles, many examples in the plants and beyond, in plants and beyond. My work was basically, is there another way of building on these superellipses, a way of capturing the geometric essence of all natural shapes? And that's when I published my paper in the American Journal of Botany, in one-step extension from Gabriel Lamé's superellipses. And that was a uniform description of many natural shapes that we see in botany. And that was a book from 2001, 2003. But we have established now that all avian eggs, all starfish and so on in the world can be done by this very simple equation. And it goes back to square bamboos that are superellipses. In 1993, that was a conjecture, but in 2020, the team of Nanjing with Pei Zheng and his students cut down a lot of bamboo culms, and they had almost perfect fit. And the original work of Pei Zheng and his collaborators go back to tree rings, also superelliptic, and that will be the first talk of today. And throughout the years, let's say, last decade, we have seen that plant leaves, avian eggs, diatoms, plant fruits, starfish, tree rings, and flowers can be modeled efficiently. And why is that important? Because then we can go from a quantitative biology to, let's say, an elliptic leaf or a lanceolate leaf. We can go to quantify all these shapes in just a few numbers, one for size and one for shape. And what is very important that I adhere always to some very simple principles of scientific or philosophy of science. It has to be accurate. Your model has to be accurate. It has to be consistent, not to deviate too much. It has to be of broad scope, going beyond square bamboos. It has to bring order in stuff. So we have a continuous transformation that unifies a wide range of shapes. And it should lead to new research findings or unveil previously unnoted relationships. And that's also the goal of the collaborations with all of you today. So there's so much to be discovered in science. But if we look at natural intelligence, how does that work? Because if we look at the tree ring problem, The formation of wood deals with stresses, builds upon what was there last year, builds tree rings, and prepares for the next year. So what we would consider in mathematics or applied mathematics as a multidimensional problem in a multidimensional space is just solved in a very, very simple way in plants in a very low dimensional way. And that's a very interesting observation for me because actually the whole industrial revolution started by the laws of motion with Isaac Newton, building up on a uniform description of planetary orbits. And these orbits were ellipses, and that's only one extension, one step away from circles. And now, if we had another step, let's say the exponent of that ellipse, we have so many more things in just one step away from Kepler's Newton. And that bites with simplicity is key. Nature does nothing in vain, as simple as possible. Now, this third edition will once again bring together the specialists from various fields. In the past, let's say I know all of the people that I invite, of course, and the idea is to get to a cross-fertilization, new insights and things, but the ultimate scientific question is always why. So now we have 2 full days in our symposium, and I look forward, of course, to all the talks, and I will thank the speakers and the attendees from let's say my heart, and I hope that new insights will follow. And one of the ideas of this natural intelligence, and so look at it, they have all the shapes that are formed have some kinds of optimal or near optimal solution to some problem. And we wish to try to find out what the natural curvature conditions in a general way are. So this year I wanted to have a bit more focus. And Bang Yancheng, I'm very proud to have Bang Yancheng and Alfonso Romero and the other speakers to give their take on cosmology. We hear a lot in Stephen Hawking and all these kinds of physicists and let's say physicists inventing all kinds of dark matter and dark energy and dark stuff. But maybe there are other ways, geometrical ways to look at it. One important thing, all these Alfonso Romero and Bang Yancheng, I've known them for almost 20 years. Dishant Pandya I also know for more than 10 years. So, and I'm very glad they participate in this conference. Later today in the afternoon, these talks, first 2 talks will be given, and tomorrow the latter 2. It's also very important to have a biological part. Sergei Petukov from Moscow will talk about logics in immunology. Genetic Boolean logical coding. Then we have Revas, who will talk about modeling in immunology. Wei Wei will be the first speaker, looking for ellipse or superellipse in tree-ring geometries. Here also on the bridge, we'll talk about plant stress and a morphology. Tomorrow, Paulo will talk about population models. And Matthew Hay will talk about Tai Chi and mass energy. Very interesting talk. But we also have various mathematical methods to look at things differently. And that will be Ilya, Sylvia. That's we have to go from natural intelligence to, let's say, artificial intelligence. And it's good to have her on looking on a mathematical point of view. Antenna arrays, and then some, let's say, more let's say, Leroy function and Early cosine series originating from physics in the high energy laser physics. And then Simone, in the next years, I also want to take a bit more on mathematics education, and Simone will talk about this. So the program is on the website. It will be like this. I also want to think that we are recording the talks. and we will put them on our YouTube channel. This is a view of the YouTube channel of Talks of Laughter. And let's say we will put also all this who wish their talks to be recorded and to put on YouTube. We will put it on YouTube for others to look at. And then I want to, from my heart, I would like to thank all of you for participating with the talk or attending the talks. And that's it. And I look forward to fantastic 2 days